Hello, this video tutorial is going to be looking at factorising expressions into brackets. And first of all, we'll look at single bracket factorisation, and then further on in the video we'll look at double bracket factorisation, which is actually quadratics. So first of all, we'll just have a very quick recap of the opposite of factorisation, which those of you that don't know is expanding brackets. So expanding brackets, so something like 3 multiplied by brackets 2 plus 5x or something like that. And just very quickly, the way we'd do this is 3 by 2, which is 6, and then we're going to add 3 by 5x, which is 15x. So that's sort of, well, it is in fact multiplication. Now factorising being the complete opposite, we're going to be looking at dividing. So, in order to do this, we'll start. In fact, I'll just get rid of this and get some more space. We're going to look at an example, and that example is going to be 3x plus 21. Now, 3x plus 21, how are we going to do that? Well, we said it's going to be dividing. How are we going to divide? And we know that our answer, we need to look something like a pair of, well, in fact, a single brackets, and we're going to have a number here, and something inside the brackets down here. So how are we going to do that? Well, the answer lies in trying to find what we call the highest common factor. So HCF for short, highest common factor. Now, to find the highest common factor, we need to find the list of individual factors for both of these terms. And what do I mean by that? Well, take the first term, 3x. We need to find the factors of 3x. And the way you can do this is to just take the number first, just ignore the letter, the x, just ignore that for a second, and take the 3. What are the factors of 3? Well, I know that 3 is a prime number, so that must mean that only itself and 1 are factors. So there we go, 1 and 3 are factors, so I know that that's complete. No other numbers go into 3 a whole amount of times. That's what a factor is, a number that divides into that number a whole amount of times, or fully. There we go. So, okay, well, what about this x? We've finished with a number. What about the x? Well, I don't know what x is. It's an unknown number. We just don't know. Until someone says to us, well, actually x is 24 or 30 or something like that, we just don't know what number it is. So therefore we don't know what factors there are. However, whatever x may be, itself is always a factor. So I can say that x is a factor of x. It has to be. Okay, so what about the next number, the next term, this 21? So we finished with the factors of the 3x. Now we need to do 21. Well, what are the factors of 21? Well, any number has factors of itself and 1, first of all, the same way that the 3 did. The 21 will as well. But what other numbers go into 21? Well, 2 doesn't go into 21 because 21 is an odd number. So what about 3? Well, 3 I know goes into 21. 21 is in the 3 times table, so I can say quite happily that 3 is a factor of 21. And what other number will I need to times 3 by to get 21? This is called the pair. So a pair of numbers, 1 times 21 is 21. What does 3 times by to get 21? 7. 3 times by 7 makes 21. And if you always kind of think of factors in pairs, so 3, 7, 1, 21 and so on, then it kind of means that you won't, well, it will reduce the odds of you forgetting or missing out any particular factors. So what do we do from here? Well, we've got the lists of factors of 3x, the list of factors of 21. So what we're aiming to do now is look for common numbers in those lists. So is in both lists, but 3 is both lists. X is not in both. We can kind of cross that out. 21 is not in both, and neither is 7, so we can cross that out. So 1 and 3 are what we call common factors. They're factors that are common to both terms or both numbers. But we said we were looking for the highest common, so the HCF. The highest one is obviously 3. 3 is the highest. The highest common factor is 3. Now, what are we going to do with 3? What's the point in doing that? Well, we said we'll divide, and actually we're going to divide both of this originally this 3x and the 21 by this height. So let's take 3x, divide that by 3. Well, what does that make? 3x divided by 3. 3 divided by 3 is 1, so it makes 1x. Or there's just x, so I'm going to put x in here. Now, this 3, the highest common factor, is always going to be on the outside. That's what the aim of it. We're going to take out the highest common factor, put it on the outside. So we've done the 3, we've done the x. Now we just need to work out what 21 divided by 3 is. Well, there's two ways of doing this. The first is to count on your fingers or do some written techniques or whatever, mental calculations. The second is which is the much easier one, is to go back to your list where you found your 21 and look at these factor pairs, this 3 and 7. Well, 7 is the factor pair of 3, which means that 3 times 7 makes 21. So actually, when you were doing 21 but divided by 3, you could just look at the list and say, well, 3 was a pair of 7, so my answer must be 7. Up to you how you do it, but it's usually quite interesting to try and save some time with maths. And again, what is the point of doing the same calculation twice when you've already done it and you've written it down and it's there in the list? Up to you though. Anyway, 21 divided by 3 is 7, so there we go. We're going to put plus 7 there. So what we've done is taken 3x plus 21 and removed or divided 3 by that. So that makes x plus 7. And you can always check your answer. This is a good thing with these. You can always check your answer by going back and do 3 times x makes 3x. But also 3 times 7 makes 21. It's 3x plus 21, which is what we started with, which was the whole aim in the first place. Okay, so that was the introduction to single brackets. It does get a tiny bit harder. So what we'll do now is look at another example, and this is again single bracket factorization. And this particular one illustrates how important it is to find the HCF, the highest common factor. So we're going to do this exactly the same way. Take our first term, 6x squared. Ignore the letters, although this is an x squared this time, so it might be a touch harder, but ignore that for a second. And let's take the 6. So what's the factors of 6? Well, I know that's 1 and 6 is the easy ones. What about 2? 2 goes into 6. How many times? 3 times. So there we go, there's the factor pair, 2 and 3. 4 does not go into 6, neither does 5. So we can be fairly confident in that we've written down all the factors of 6. But what about this x squared? Well, the easiest way to do this is say that x and x squared are factors. If it was x cubed or x to the power of 4, then it's all of the powers up to and including that. So x cubed, for example, will have factors of x, x squared, and x cubed. So it's nice and easy. All you need to do is include all of the powers up to and including the one in question. So, let's get rid of that. Okay, so we have finished the list of factors for this 6x squared. What about the 18x? Well, in exactly the same way. We can say 1 and 18 are factors, itself and 1. What about 2? Well, 2 goes into 18 9 times, so there's the factor pair of that. Well, what about 3? 3 goes into 18 6 times. Okay, what about 4? Nope. What about 5? Nope. What about 6? Well, we've already included a 6 here, so that means that we've actually completed our factors of 18. What about the x then? Well, as we've already said, x is a factor of x, and that's it. So we've finished our factor lists. Everything's in pairs. It's all nice and neat. So now we're going to go ahead and circle what we call the common factors. So there's 1 and 1, 2 and 2, 3 and 3, and it's just an observational thing really. There's 6 and there's 6. What about x? There's an x. X squared? Well, no, it's not actually, so that's cancelled. 18 and 9 are not common. So there we go. We've got quite a large list of common factors there. But again, we're looking for the highest common factor. Now let's just have take a second to think about this. Well, we've actually got the highest number, which is 6. But there's a letter as well. A letter is common. You have to include the letters. So it's actually 6x. If there was an x squared in both of them, then we'd include the x squared as the highest common factor. So x squared is higher than x cubed is higher than x squared, and so on and so forth. So there we go. There's our highest common factor is 6x. So with our brackets, we'll do 6x on the outside. Here we go, nice and spacious. And we're going to divide both of these terms by 6x. So this is a bit more algebraic, I suppose. So what is 6x squared divided by 6x? Well, we can take the numbers first. You don't have to consider it all as one because it can look quite daunting. So take the numbers first. 6 divided by 6, well I know that's 1, so I'm going to put a 1 there. And now we take the letters. What is x squared divided by x? Well, this x is like x to the power of 1. So x squared divided by x, if you think about your laws of indices and the rules of powers, when you divide, the powers are, we subtract the second power from the first power. So that's 2 take away 1, so that's just actually x to the power of 1. 1 times by x to the power of 1, well that's actually just the same as x. So what we're going to do is put x in here, because we've done 6x squared divided by 6x. So that's what it goes there. And if you think about it, we multiply that out and we get 6x times by x, which makes 6x squared, which is exactly what we started with from the question. So that we know that that bit's right so far. Okay, well we'll now do the 18x and we'll divide that by 6x and see how that works. Well, same again, numbers first. 18 divided by 6 makes 3. X divided by x, well that actually just makes 1. So it's like 3 times by 1, or just 3. So we're going to put 3 there. 6x times by 3 makes 18x. So we know that's correct, and it looks correct as well by recalculating and doing the opposite of factorising, which is the expanding. The important thing to note with these is if you don't use the highest common factor, let's say for instance you missed that there was a 6 there or something like that, so you would have crossed out the 6 and you said that, I don't know, 3x was the highest common factor, then what would have happened? I'll just write this here just very quickly. If we had 3x as the highest common factor, it would still work, but it wouldn't be fully factorised because we'd have 3x on the outside, and what would we have in the inside? We'd have 2x here, because 3 times 2 makes 6, and x times x makes x squared, so 6x squared. And then 18x divided by 3x just makes 6. So you'd have a factorisation of sorts, but it wouldn't be fully factorised. And you can see that because this 2 and 6 still have a common factor. 2 and 6 have a common factor of 2, so we can still actually take 2 out of this factorisation. So again, just be careful that you use the highest common factor, which is why we try and write these lists of factor pairs down. Okay, so the next part of this is to look at double bracket, or what we call quadratic factorisation. So just as a introduction, we'll just very quickly remember how to expand a double bracket, which is using something like a table. You can do it how you want, but we'll just use this table for this particular one. Again, there is another video on how to do this. So this bit here, and so we're multiplying all these out: x squared, 3x, 6, and that's a 2x. So this bit here, the 2x and the 3x make 5x, so we actually get x squared plus 5x plus 6. So that's how we do the expansion. But now we're going to look at what the opposite of expansion, which is the factorisation, which is basically starting from here and going back up to here. So how do we do that? Well, there's various ways, and it depends on the complexity of the question. So I'll just I'll keep that for the moment. There we go. Up there. So let's take a different example. Well, something like x squared plus 9x plus 20. Well, how are we going to do that? Well, I know that I need to get it into the form of this, so a double set of brackets. But what's going to go where? Well, let's just have a quick look in this example. To get x squared, which is exactly the same here, we have an x here and an x here, because when they multiply together we get x squared from this bit here. So I know that I'm going to have an x and an x. X times by x makes the x squared. Now, what about how to get this number on the end, this 20, or in this other example it was a plus 6? Well, I know that this 6 comes from this bit here. 6 was the 3 times by the 2, which were just the numbers here and here. However, I could just say, well, 6 is what do I need to times together to get 6? Well, is, I don't know, 1 and 6 or 2 and 3. So how do we know that it is this 2 and the 3 from here? Well, it all comes down to what the number is in the middle, this 5x bit. So let's go back to this example. We'll close that one off for now. So I know that 20 must come from the multiplication of the numbers here and here. But there's various numbers that multiply to give 20. So what we're going to do is write down, again, the factor pairs of 20. So nice easy ones, 1 and 20, 2 and 10. 3 is not a factor, 4 is. 4 is a 4 and a 5. What else? 6 doesn't go into 20, 7, 8, 9 and 10 we've already done. So there we go. These are all of the factor pairs of the number 20. So what numbers will we choose? I mean, I could say that 1 and 20, so positive 1 and positive 20 go in here. But that wouldn't actually work out that well because, and we'll have a quick look why, if we have x plus 20 here and x plus 1 here, although the x squared works, so that's nice, and the plus 20 works, 20 times 1, that's fine. When we get to doing the other two bits, we get 20x and we get 1x. Now 20x add 1x is 21x, which if we look here is not correct. So we can actually cross off this 1 and 20. So then we can try the next one, which is 2 and 10. So if I change this to a 2 and this to a 10, then this would, in fact, we'll start a new one. And sometimes it is just trial and error. It does take a bit of practice to be able to do it without trial and error, because you can think about it a bit more in your head. But for this one, we will just do trial and error. So this x times x is x squared. The 10 times x is actually 10x. The 2 times x is 2x. And this is 20. So again, the 20 and the x works, but this 2x plus 10x is 12x, which again is not our 9x that we're looking for. So again, 2x and 10, the 2 and 10 is wrong, which only leaves one more left. So let me just remove this to make some more space. There we go. So what we're looking for then is not this, but x plus 4 times by x plus 5, and hopefully that's going to work. So let's just do one more double check. So we've got an x plus 5 here and an x plus 4 here. X squared, 5x, x times 4 makes 4x, and then 4 times 5 makes 20. So again, 20 works, x squared works, but when we look at this, 4x plus 5x, that actually makes 9x, which also works. So it's this middle bit, this x part in the middle, that's the key, and that, as long as the two numbers from your table add up to give that middle 9x or whatever it might be in your particular question, then we can say that it actually works. And it does unfortunately involve sometimes a bit of trial and error, unless you've got the practice and the foresight to do some of it in your head. But I would always recommend writing everything down. So that was the first example of a quadratic factorization. So the next thing that we need to do is look at some slightly harder ones. So 3x squared minus 8x minus 3. Now this is hard for various reasons. The first being this 3. The other ones that we've looked at so far, well in fact the only one that we've looked at so far, just had an x squared. But this has got a 3x squared, and that has some implications, and we'll look at that in just a second. The other reason why it's hard is because of these little babies here, these negative symbols. Minus and negative numbers are always a big cause of error in any kind of examination or problems or questions or anything in maths. So you have to be very careful with those. So how do we do this? Right, okay, well then, we knew that we need to get it into some form of double brackets. But last time we said, well, there was an x and an x that went here. But that was because in our table here, we had x times by x, which was making an x squared. But clearly in this case, we've got a 3x squared, which means that one of them needs to be a 3x. Because 3x times by x makes 3x squared. So there we go, we know that 3x and x has to be there. So that's the reason why it's slightly harder for that. So you need to give that some consideration. But the next step was saying, well, what are the factors of this last number? And in this case, it's a negative number, -3. So we have to include that negative. Remember, the signs of a number or a letter are always on its left-hand side. So the negative is on the left of the 3, so it is included with the 3, and it's a -3. So what are the factors of -3? Well, first of all, what are the factors of 3? Well, I know that 1 and 3 are. It's a prime number. 3 is a prime number, but this is a -3. So one of these numbers has to be negative. And the big question is, which one? Well, if I said that -1 is negative, then it must mean that the 3 is positive, because -1 times +3 is -3. However, that doesn't have to be the case. What if I had a positive one? Well, that would mean that I have to have a -3. And although these look very similar, they are actually different, and you need to include both of these in your list of pairs. So I know that I've got 2 factor pairs of this -3, but the big question is, which one goes where? Well, what we're going to do is just try them out. It's just a trial and error exercise again, until you can get enough practice that you can sort of have a bit of foresight in your head. But again, still try and run it down. So anyway, we'll put the -1 and the +3, which is this one, into here. And when we do that, I'm going to also put them into our little table. So this x +3 and 3x -1. And I'm just going to give it a go and try and get the correct answer. So anyway, 3 times by 3, 3x times by 3, sorry, that makes 9x. What about x times -1? Well, that makes -1x, or just -x. -1 times by +3. Well, minus times a positive is a negative, and a 3 times 1 is 3. So with this one, -3 is good, 3x squared is good, but what about this addition of those same numbers in the middle? We're looking for -8, but 9x take away x is actually 8x. It's actually a positive number, positive 8x. So this particular arrangement is wrong. But before you cross these ones off with negatives, before you cross them off, always think about, does it make any difference if I swap this +3 and the -1 around? So for instance, if I said 3x +3 times by x -1. So the same factor pairs, still this one here, but swapping them around now. And when we're to draw out our table, and we get our x take away 1, 3x +3, I know that the 3x squared is still good, and that the -3 is still good. From up here, we know that 3x squared and -3 are correct. But when I do 3x times by -1, that makes -3x. And when I do x times +3, that makes +3x. So actually, 3x take away 3x is still not 8x. So only at that point, once you've tried it in both ways around, both brackets, you can cross off this. Okay, so let's make some room. I know that those first factor pairs are incorrect. So what I'm going to do now is try the next one. 3x times by +1 from here, and then x times x take away 3 from this one here. So 3x +1 and then x times take away 3. Let's do this. 3x oh no, let's do it the original way that we were doing it. So x take away 3 here. It doesn't really matter what way you put them around actually. And then the 3x +1. 3x squared is good. -3 is good. Now we've got 3x times by -3. What is 3x times by -3? Well, it's -9x. Negative 9x. x times by 1 or plus 1 is just x. So again, all we're looking for is these two to still be is to create or add together or join together, whatever you want to call it, to create this minus 8x here. But we've got minus 9x and we've got plus x. So that actually makes minus 8x. So that is correct, which actually means that after a bit of trial and error, this is the complete factorization of a fairly complex quadratic into double sets of brackets. And that actually brings us to the end of this video tutorial. So if you want to have a look at anything more, you can download from the CyberTutor downloadable documents in the library. Thank you. So if you want to have a look at anything more, you can download from the CyberTutor downloadable documents in the library. Thank you. Laura, so here's a single bracket expansion. Are you happy to give that a go?
Yeah. Would it be 6x plus 5?
No, actually, it's not quite that. Not quite right. Do you want to give it another go?
Oh, was it 3 times 5 as well?
Yeah, 3 times 5 as well.
So it'd be 6x plus 15.
Yeah, perfect. Well done.